Hello, in this video we will see on Fifo. I am doing this under the guidance of Dr. U.p.Kulkarni, Department of Computer Science and Engineering, SDM CET, Dharwad. So what is Fifo? Fifo stands for first in, first out. It allows two unrelated processes to communicate with each other. They are also known as named pipe. It is used to establish a one-way flow of data. A pipe is a section of memory that is used for inter-process communication. A named pipe can be described as first in, first out, that is FIFO. The inputs that enter first will be output first. Now let's see some of the features of the named pipe. It exists as a special files in the physical file system. Any unrelated processes can access a named pipe and share data through it. Access to the named pipes is regulated by the usual file permissions. Pipe data is accessed in the FIFO style. If the named pipe is once created, a named pipe remains in the file system until it is explicitly deleted. Now we will see some of the difference between the pipe and the FIFO. Pipe is a structure of a data which is contained into the memory. It is removed when existing process terminates. Basically, a pipe is used to communicate between two or more related processes. If pipe is already in the open state, then it does not need to be opened. Pipe provides a simplex data flow. This is the syntax to create a pipe. Now FIFO. Unlike pipe, it is a structure of the file which is created in the disk. It is used for the communication between unrelated processes. It should be opened every time when it needs to read, write and read. FIFO provides half duplex data flow, and this is the syntax to create a named pipe. Now we will see how the named pipe works. It uses an access point. A file on the file system. Two unrelated processes opens this file to communicate. One process writes and the other reads. Thus it is a half duplex communication. One process writes and the other process reads. Thus it is a half duplex communication. Now we will see some of the properties of the named pipes. Named pipes are system persistent objects. They exist beyond the life of the process. Named pipes must explicitly deleted by one of the process by calling unlink. By default, it supports blocked read and writes. That is, if a process opens the file for reading, it is blocked until another process opens the file for writing and vice versa. This can be overridden by calling o_non-block flag when opening them. A named pipe must be open either read-only or write-only because it is a half duplex, that is one-way channel. Now we will see how we can create a named pipe. A function makeFIFO can be used to create a named pipe. This is the syntax to create a named pipe. That is int makeFIFO. It takes two arguments, one is path and one is mode. It creates the new named pipe file as specified by the path. Mode parameter used to set the permissions of the file. This function creates a new named pipe or returns an error of E exists if the named pipe already exists. makeFIFO fails when the file with a given name exists, if the path name is too long, a component in the path name not searchable or non-existent or non-directory, destination directory is read-only, not enough memory space is available, signal caught during the makeFIFO. Now we'll see how to open a named pipe. A named pipe can be opened for reading or writing. It is handled just like any other normal file in the system. Example, a named pipe can be opened by using open system call or by using fopen standard C library function. Once you have created the named pipe, you can treat it as a file so far as the operations for opening, reading, writing and deleting are concerned. This is the syntax to open. It takes two arguments, one is the path name and another is a flag. So these are the some of the possible flag that we can pass in this open system call as an argument. First is O underscore read only, RD only. This is for open for read only. O underscore WR only. This is for open for writing only. O underscore RDWR. This is for open for read and writing. O underscore non-block. It says do not block on open. O underscore append on each write. O underscore create, create file if it does not exist. O underscore truncate size to 0. O underscore excl, error if create and file exist. O underscore sh log, it automatically obtain a shared log. O underscore ex log, automatically obtain an exclusive log. O direct, eliminate or reduce cache effects. O underscore f sync, it describes synchronous writes. O underscore no follow, does not follow system links. Now we'll see how we can read from and write to a name pipe. Reading from and writing to a name pipes are very similar to reading and writing from or to a normal file. A standard C library function calls, that is read and write, can be used for reading from and writing to a name pipe. These operations are blocking by default. A name pipe cannot be opened for both reading and writing. The process opening it must choose either read mode or write mode. A pipe open in one mode will remain in that mode until it is closed. Read and write operation to a name pipe are blocking by default. Therefore, if a process reads from the name pipe and if the pipe does not have data in it, the reading process will be blocked. Similarly, if a process tries to write to a name pipe that has no reader, the writing process gets blocked until another process opens the name pipe for reading. This, of course, can be overridden by specifying the O underscore non-block flag while opening the name pipe. Now we will see the program that implements a name pipe. This is a client-side program. We need to include these header files. Hash include stdio.h, which includes standard input output operations. Hash include string.h, which includes string operations. Hash include unistd.h. It defines the miscellaneous symbolic constant and types and declares miscellaneous functions. Hash includes sys/stat.h. It defines the structure of the data written by the function fstat, lstat and sstat function. Hash include fcntl.h. fcntl describes file control options. fcntl stands for file control options. It defines the following requests and arguments for use by the function fcntl and open and can be used to. It is used to retrieve or modify open file flags given a file descriptor. We are defining two Fifo files, Fifo1 and Fifo2, and we are setting permissions to 0666. That stands for we are giving read and write permission to users, groups and others. We are declaring size underscore t. This data type is used to represent the size of a blocks that can be read or written in a single operation. We'll open the file in write-only mode. Then we will open the Fifo2. First Fifo1 will open in the write-only mode. Open system calls takes two arguments. One is path name and another is flag. Path name is Fifo1 and the flag that we are using is write-only. And similarly, we are opening the Fifo2 in the read-only mode. Now we are requesting the file name from the server. Enter the file name to request from server. We are reading the file name. Then we are writing the content of file using write system call. Write system call takes three arguments. One is the file descriptor, one is the buffer, that the pointer that points to the memory location of the file, and a size of the file, that is s size underscore t. Then it reads, then it writes to a buffer. It read also takes three arguments. One is file descriptor, one is buffer, then one is size. Then finally we are closing. Read ft and write ft. Now we'll see the server side program. Again we need to include these header files. Again we are defining the Fifo and we are setting the permissions. Here we are creating a name pipe using mk Fifo. We are giving path name as Fifo1 and mode as permission, that is 0666. Read and write permission for users, groups and others. First we are if make Fifo it is less than 0, then we are printing can't create Fifo files, then exit 1. Similarly for Fifo2, then we are opening Fifo1 in a read only permission and Fifo2 in a write only. Then we are reading. Then we are displaying the file name. Client has requested for the file name. Then we are opening that file. If it is less than 0, then file does not exist and exist 1. Otherwise, if the file exists, then we are reading the file using read, and finally we are writing the contents of the file using the write system call. As name pipe remain in the system, we need to explicitly delete the name pipe. That's why we are using unlink to delete the Fifo. Unlink Fifo1 and unlink Fifo2. This is the output. Now we'll see some of the advantages and disadvantages of the name pipe. Advantages are: name pipes are very simple to use. Make Fifo is a thread safe function. No synchronization mechanism is needed when using a name pipes. Name pipes have permission, read and write associated with them. Unlike anonymous pipes, these permission can be used to enforce secure communication. Now we'll see some of the disadvantages of the name pipes. Name pipes can be created only in the local file system of the host. That is, it cannot create a name pipe on the NFS file system. Careful programming is required for client and server in order to avoid deadlocks. Name pipe data is a byte stream and no record identification exists. So these are some of the advantages and the disadvantages of the name pipe. These are some of the references I have used for this video. Thank you.